But let us now discuss about a few applications of dimension reduction. If you try to run a regression model which has one output variable and say 200 plus input variables, it would be computationally very expensive. It would be very time consuming. You will have to use high-end computers to perform operations. And if you have such a huge data, and if you were to do real-time predictions, that is when your computational performance would further dip. For example, your stock market. You will have to probably forecast on what will be the stock value for the next second, for the next millisecond, for the next microsecond. And the speed at which your model has to be rebuilt would increase exponentially depending on these kind of dynamic business cases. Under such scenarios, you can probably reduce these variables to say 10 variables. I'm not speaking here about deletion, right? We are not speaking about deleting 190 irrelevant variables and considering only 10. That is not what we are speaking about. We are speaking about mathematically transforming the 200 variables in such a way that the information captured in all 200 variables gets captured in probably 10 variables. That is the intention of dimension reduction. It's not deletion. Apply a mathematical transformation so that information contained in 200 variables is collected in probably 10 variables. Okay. It is also heavily used in your face recognition algorithms. For example, your Facebook uses an algorithm called as deep face. And this deep face algorithm is expected, or that is what your Wikipedia says, that the accuracy of deep face algorithm is 97%. If you upload a photograph on Facebook along with your friends, right? You have taken a photograph of you and your friends and you upload that onto Facebook. Deepface would try to scan that particular image and it would automatically tag the names of your friends. That's the beauty of Deepface algorithm. And the accuracy is 97%, and it is a touch above than your intelligence departments. Let me show you that. If I'm not mistaken, it should be 97%. But just to make things very clear, we will be, one second. Let me do this. Here I'm going to search Facebook Deepface. Where did that go? I think, look at the irony, look at the tragedy, right? When we use Google search, it is so accurate. And look at this. The accuracy has only gone down significantly. I'm unable to see that Wikipedia. Let me open instead google.com. Wikipedia, Facebook, Deepface. There we go. Look at this. This is why people resort to Google search engine, right? This is why people do not use Bing or Yahoo, etc. Pathetic results. I've searched using this and it's not even giving me a single search which is relevant. It has given me a search which is irrelevant. That's in a different language altogether. Anyways, there we go. Deepface is a deep learning facial recognition system which was created by a research group at Facebook. It identifies human faces in digital images, and this particular model was trained on 4 million images. Uploaded by whom? Uploaded by the Facebook users, you and me. And the system is 97% accurate, and compared to 85% accuracy which FBI's next generation identification system has. Right? It is far more accurate than your FBI. That is what this is all about. Okay. And you'll have a lot of videos, right, that are getting uploaded onto YouTube, on your social media, on your WhatsApp, etc. Videos tend to consume a lot of size, a lot of space. Videos tend to have a lot of dimensions. We need to compress that. We need to reduce that. Okay. And the same goes with your image compression also. If you have an image which is of a lot of pixels, then how do I compress that so that computation is very easy? Think about your Google driverless car, right? In this Google driverless car, you know, there would be cameras available which will be fixed at the start, at the bonnet of the vehicle, and it's going to continuously record the video, capture the images of street, of maybe a pothole ahead, of maybe a signal, so on and so forth. And these images should be analyzed within a split second. Within a split second, a message has to be sent to the driverless car that it has to apply brakes if there is a pothole ahead. Within split second, it has to probably take a left turn or a right turn. If there is a pedestrian who suddenly runs onto the street, you have to apply brakes. And imagine the computational burden that the computer or your system would have if the images and videos are getting recorded 24/7 or at least live when you drive the vehicle, right? So in these kind of instances, yes, your dimension reduction techniques come in extremely handy. Your drone, nowadays it's the age of the drone. Recently I read an article wherein one of the aircrafts, passenger aircraft, had a close shave with a drone. Drone also was flying in, the airport perimeter, and the passenger aircraft was, about to land, and there was a close shave basically. So all these things are happening because drone requires a lot of training, right? If you do not train this drone with a lot of images, it should recognize that a flight is coming, a flight is nearby, right? A flight is landing. It should be in a position to differentiate between a flight and a bird, etc. Right? So hence, there's a lot of training that drones should undergo, and dimension reduction comes in very handy to analyze those images and help drone recognize on what that particular image is all about. And now, do you know what? License plates are being mandated in US. Your drone should also have license plates similar to your car or bike or any other vehicle. And there will be a few other drones which will be policing your drones. There'll be traffic police in the sky, looking at various drones, trying to regulate the traffic, so on and so forth. Image recognition, your face recognition is extremely famous in the current world. Not just drone, right? You can think about many such applications. For example, I can give you another example wherein a drone which was size of a honeybee, right? That has ventured into a secret zone and it was capturing a lot of, secret information. How do you capture this? How do you even come to know that this is not a honeybee, this is a drone? For that you need some kind of a camera, right, or some kind of a sensor which would quickly recognize this. And what usually happens is the image of this bee which has just entered, say, White House in US would be quickly compared against all the live bees, right, all the real bees, real honeybees, and they quickly look into the matches. If at all there is any mismatch, then they're going to get hold of this. So they're using bigger drones, and the bigger drones would come with net, and they're going to capture your smaller bees, or if at all that's a drone. Not just this, recently another article on Economist, I wish to show you that, has shown that there was a drone which was Chinese make, which was found in the compound wall of Washington, White House. That's an alarming thing. So maybe people are trying to venture into your private zones, try to capture the images and videos. Maybe they want to get the secret information out. Hence, your image processing becomes extremely relevant in the current world. Let me show you that article. So I'm assuming that that was there on Economist. Let me do this. I think it's Age of the Drone, the article name. Hopefully we'll find one. Yep, this one. And these drones are heavily used even in the warfare, in the wars, right? US has been using this heavily, and a lot of your head of ISIS, head of Taliban, etc., they're being shot down thanks to drones. Yep. So, oh, come on, what is this now? Once again, I think I need to refresh this. Let me close this. Okay. So, American Federal Aviation Authority estimated that by 2020 there will be 15,000 drones in the country. 15,000 drones. Wow. Yeah. Amazon has started delivering its products through drones. That's the amazing part. So this would be the future, friends. Not just building your prediction models, which has more or less become naive now. Replacing your air traffic controllers with drones, the ground personnel with drones. This is what is artificial intelligence all about, right? So machines are coming for your jobs, and machines require good training before it can, replace humans. This would be an interesting area to actually perform research on.